Welcome back. In this last video, we're going to look at distance. So distance on a number line, you can subtract the smaller value from the larger value to find the distance between 2 points. So when I look at this, if I want to know how far it is from A to Z or from Z to A, you can go either way because distance is always positive no matter which direction you go. But if you want to do it mathematically, you're going to take your larger value, which between 9 and -7, 9 is definitely bigger, and then you're going to subtract from that the smaller value, and my smaller value here is a -7. Remember, your double negative really turns into a positive, so 9 plus 7 is 16. So 16 is the distance from A to Z, 16 units. We can also count. The problem is some of us, when we count when we start putting our pen down. So we say 1 right here, but we haven't actually moved. So make sure you don't start counting until you move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we can see we have 16 units between A and Z. Okay? On a coordinate plane, you have two options. You can use your distance formula, d equals the square root of x2 minus x1 squared, plus y2 minus y1 squared, all of that under the square root. Or you can actually apply the Pythagorean theorem, a squared plus b squared equals c squared, to find the distance between the 2 points. So when I look at the example that I have here, my 2 points, let's see, my first point is the point, let's call it this one over here. It's going to be 3, and then 1, 2, 3. It's 3, 3. My other point is at, -3. Lots of 3's in this problem. And 1, 2, 3, 4, 5. Okay, so those are my 2 points. If I want to use the distance formula, the first thing I always like to do when I'm using the distance formula is I write the distance formula without the x's and the y's. So d equals the square root of parentheses x2 minus close squared plus parentheses y2 minus y1 close parentheses squared. So that way I can just plug my x's and my y's in. Okay, so we want to make sure we know what point we're using for what. So if I look at this point right here and I call this my first point, it's going to be my x1, y1, which means this will be my x2, y2. Okay, so when I plug into my formula, let me make sure I can see my graph and my formula at the same time. When I plug in, x2 is -3, x1 is 3, y2 is 5, y1 is 3. Okay, so from there, now I can start solving. So my distance equals the square root of, now be real careful, -3 minus 3, a lot of us get real quick and we accidentally say that's 0. But -3 and then you go even 3 more negative, right? You take 3 away from, you're at -3. Look up here at this number line. -3 and then I take 3 away, I end up at -6. Plus 5 minus 3 is 2. So then my distance equals the square root of -6 squared. Be careful. A lot of times if you just put -6 squared in your calculator, you're going to get a -36 because you forgot parentheses around the negative and the 6. When you square a negative, it always becomes a positive. Plus 2 squared is 2 times 2, which is 4. So my distance equals the square root of 36 plus 4, which is 40. So my distance is the square root of 40, which when I round to 3 places is 6.325. Okay? Now I did say you can also use the Pythagorean theorem, so I do want to show you that as well. For the Pythagorean theorem, what we're going to do is we're going to kind of like looking at your slope. How far up and over do you have to go to get from one point to the other? So I have to go up 2 units, and then I have to go over 1, 2, 3, 4, 5, 6 units. Okay, so notice what I made when I looked at how far up and over. I made a little right triangle where I'm just trying to find the hypotenuse. So my a squared, which is 2, plus my b squared, which is 6, equals my c squared. So my 2a squared plus b squared equals c squared. And my two sides are the 2 and the 6, and you can put them in either order. So 6 squared plus 2 squared, which is kind of interesting. Look right here, 6 squared and 2 squared. I just have a negative there. Equals c squared. 6 squared is 36, plus 2 squared is 4. Look, that's what I have there. Equals c squared. 36 plus 4 is 40, which is what I have there. Equals c squared. To get rid of the square, we square root, which is what I have there. And I end up with the square root of 40, which we already know is 6.325, equals, over here my square and my square root cancel out, and I just have c. So either way that you do it, your answer is 6.325 units. So you can use either method. This one just algebraically calculates that 6 distance and that 2 distance is all that it's doing. Okay? And the last type of distance we looked at in this unit 1A was fractional distance. For fractional distance, we need to multiply the fractional distance by the whole distance, and then we're going to subtract it from the appropriate endpoints. So here's what we're doing. We need to first find, if I want to know what 3/4 the distance from Z to A is, I'm going to multiply 3/4, the fractional distance, times the whole distance. And we already did this one. This was the one that we looked at up here, where my distance, we did 9 minus a -7, or you could count either way, and we got a total distance of 16. So again, you can either subtract or you can count to get your 16 from A to Z. Okay, so 3/4 times 16 is 12. Okay, so then we are going to look at where our starting point is. So this is important to look right here. We're going from Z to A. So if I'm starting here at Z and I'm going towards A, I'm going backwards. Since I'm going backwards, I'm going to the left. That means I'm going to subtract. If I was starting at A and I was going towards Z, I'd be going forwards to the right, so I would add. Okay, so if I'm starting at Z and Z is at 9, I'm going to subtract 12 to find where my point should be. So 9 minus 12 is a -3. Okay, so -3 is right here. That is 3/4 the distance from point Z towards point A. Okay, and we can kind of see that because if I know the whole thing is 16 units, if I divide it into 4 equal parts, each part would have 4 pieces, right? So I would divide it here, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then if I want it, so that's 1/4, 2/4, 3/4, 4/4, right? So 3/4 puts us right here at this -3. Okay, thank you so much for watching.